Hey guys, this is Miss Moore. So what I decided to do so that we can actually spend time in class working on memorizing all those bones we have to memorize, I'm going to go ahead and make our final video on the bone physiology so you can do it at home. I'm going to give you, you should have some notes right now that you picked up in class and taped in your journal to copy from. I'll be checking these, let's just say by Thursday, I'll be checking them for a completion grade, okay? All right, so let's go ahead and talk about it. So this is about bone development. So make sure you're following along with your notes right now. If you miss one and you don't know what it is, or you're confused, you can always ask me in class, okay? All right, so the first step in bone development and bone growth is that everybody's bones, when you're a baby, they start as hyaline cartilage, okay? So that's why babies are kind of flexible and bendy, is because they start out as hyaline cartilage. Over time, the cartilage is going to change to bone tissue, and this is called ossification. I think that's on your notes. It's called ossification. That's the process of cartilage changing to bone. All right, and I'm going to skip over that real quick. All right, so step one. So this is step one in your notes. So this process is specifically called endochondral ossification. So just keep that in mind. So ossification is bone formation. The fetal skeleton is composed of hyaline cartilage. Okay, so step one in your notes. Every bone starts out as a hyaline cartilage model. That's what it's called. I didn't make that up. It's called a hyaline cartilage model. If you look at this picture right here, this whole bone, or what will be a bone, starts out as just hyaline cartilage. But notice it's in the shape of a bone. It still has the epiphyses on the ends, the diaphysis in the middle. And then it has a membrane around it called the perichondrium. So we talked about a periosteum. That's the membrane around the bone. The membrane around cartilage is called a perichondrium. So this is step one. Nothing's really happened yet. All right, step two in your notes. So if you remember from our tissues unit, every single connective tissue starts out as a mesenchymal stem cell. So remember, bone is a type of connective tissue. So its precursor cells are going to be mesenchyme. So what happens is, underneath the membrane that surrounds the bone, the perichondrium, you're going to have mesenchymal cells that are just kind of chilling out for a little bit. Over time, signals are going to be sent off to differentiate. So these mesenchymal cells are going to differentiate into osteoblast. All right, remember, these are cells that are going to make bone. The word blast means something that's immature. Okay, let me turn my diffuser off. I feel like it's making noise. There we go. So these osteoblasts are going to form something around the hyaline cartilage model that's called a bone collar. All right, this is a real term. So the cells that are going to be inside here, they're called chondrocytes. All right, so that's what's going to be making up this hyaline cartilage model. So this bone right here, picture if you had a collar that was made out of bone, right, around your neck. So you would be choking. Okay, so that's what's happening to these chondrocytes inside this bone. This bone collar that's starting to form the bone around it, it's strangling the cells that are inside this hyaline cartilage model. Okay, so this is step two. So osteoblasts underneath the perichondrium are going to form a bone collar around the edge of it. All right, endochondral ossification, step three. So like I said, the bone collar around this bone is causing these chondrocytes to kind of be strangled in a way. So they're going to want nutrients sent to them, all right? So what's going to happen is this little bud right here, this periosteal bud, is going to literally go through this bone because it's an emergency situation. The chondrocytes in here need nutrients because it's being cut off by the bone collar. So this bud's going to go through, and it's going to try to deliver nutrients ASAP. All right, it's going to try to deliver them ASAP to the chondrocytes. But on the way, the osteoblasts and osteoclasts are going to hitch a ride with the nutrients and oxygen into this. All right, so it's like, oh, I'm going to jump on this, and we're gonna hitch a ride into the bone too. All right, so they're going to go in there. So osteoclasts are going to eat away all this cartilage right here, and it's also going to form the medullary cavity that's in the middle that bone marrow forms in. So that's what the osteoclasts are going to do. In the meantime, the osteoblasts are going to be forming more bone on the inside to get rid of this hyaline cartilage model right here. All right, so right now, this is just occurring in the diaphysis of the bone. Notice that nothing's happened on the ends of the bones. These are called the epiphyses. Nothing is happening yet. This is all in the diaphysis of the bone. Step 4. All right, so the blood vessels are going to start penetrating the epiphyses of the bone. So right now, the diaphysis of the bone's all good. It has bone in it. It has the medullary cavity where bone marrow is going to be. So now we're going to need the ends to form the bone too. So the blood vessels are going to penetrate the ends. So it's going to penetrate the epiphyses, and bone's going to start to be formed here. This is called the secondary ossification center. So this right here, this first step is called the primary ossification center. So that makes sense. This happens before the ends. All right. So that's the next step. All right. So this is kind of like the end result right here. So the only thing that's going to be left that has cartilage on this bone is going to be the articular cartilage. And we have that right now. And that's to reduce friction. So you don't want your bones rubbing against each other. That would be really bad. So the articular cartilage is going to stay on the ends of the bone. That's never going to be ossified. The other thing that's going to still have the hyaline cartilage is going to be the epiphyseal plates right here. You might have heard your doctor say they're called growth plates. They're going to stay cartilaginous. Am I saying that right? Anyway, they are going to still have cartilage on them. And the reason why is so that your bones can grow. All right. So as you're growing, you are having cartilage right here at these growth plates right here. Okay. Cartilage is going to expand really easily. All right. So it's going to grow up and down. Okay. So that's how your bones are going to increase in length there. Over time, this plate right here is going to be ossified. We're not going to grow anymore. So it's going to be ossified. Like I just said, 2 regions that are not going to be ossified is the articular cartilage. It persists for the rest of your life, and it reduces friction. And also the growth plates right here. And that's just so you can grow. So I remember my brother, when he was little, we were wondering if he was going to grow anymore because he was so tiny for the longest time. And so my parents were kind of wondering, like, is he going to be 5'2", just like my mom is, or is he going to grow? And so they had an x-ray done of him, and the doctor realized that he still had plenty of room for growth. So what they do is they take an x-ray of a bone and kind of look at this growth plate right here in the epiphyses to see if there's still this plate or these spaces right here. And notice in this person there is. Okay, so here's a child's knee. You can see that there's plenty of space right here, but this is an adult knee. Notice that there is no growth plate here. Those plates have been ossified. Okay. And by the way, he's like 6 feet tall now, so he definitely grew. All right, so I'm going to end there for the ossification video, and I'll pick back up. I'll make another video for bone fractures. So I'll see you in that next one.